After substitution, the last integration to be done is integration by parts. That's like product of two functions that substitution cannot take care of. So it's like the reverse of product rule. As a matter of fact, you can generate that formula using from your product rule. But we are not going to generate it. They are all stated in your formula booklet. You just need to know when to apply them. Okay? So you can see that when you have rational function, it could go in the way of f prime x divided by f of x, which gives you natural log. Okay? It could also go in the way of resolving to partial fraction first. Some rational function cannot be solved by these two techniques so far. Okay? You have to use substitution. Okay? So let's begin with, I also had mentioned this before. Indirectly. I used substitution when I was establishing the pattern of f of ax plus b. Remember? F of ax plus b, how we introduce u is equal to ax plus b, we transform the dx to du. That is what substitution is about. Okay? But there are more difficult functions, like the arctan, which are already established, but we will just go through with how is it done when you introduce x is equal to sine theta, y is equal to x is equal to cos theta or tan theta. How is it normally generated? But I don't think you need to worry about that unless it is specified. So let's just take some random questions. So in number 1, I'm going to take question. I want to take one question, or maybe B and E. Let's take one B and E. Okay? And if time permits, we take one in number 2. Then you can practice within number 1 and 2 between now and tomorrow. Don't go beyond so that you are not overwhelmed by a lot of stuff. You still have a few questions in the partial fraction. Yes. How many more questions in partial fraction? I think I put 8, right? Yeah. And you've been able to do like 3 in the class. So you still have about 5 of those. So I wouldn't expect you to spend so much time on all these questions. How many? There are 16. So don't go beyond. If you need to practice anything here, don't go beyond 1 and 2.
You repeated it 4 times.
What?
You repeated the question 4 times.
I repeated question. Question what?
9.
Question 9. Oh no! I was supposed to edit that and put different functions. Oh no!
It's okay.
All right, so we just have 3 questions there.
Oh yeah.
Just question. Oh my no! Oh no! Anyway, so let's take 1b. 1b says integrate x squared exponential x cubed plus 1 dx using u equals x cubed plus 1. Please pay attention. Okay? So you have been told what your u is. So the first set of questions, I kind of spoon-fed you what u should be. So over time you will see why we are taking some functions of u. Then you'll be able to decide yourself, because of course IB will tell you u is equal to. I don't think there's any IB question that says using u. Oh, they're nice too. If you look at the last 4 questions or 5, using substitution u is equal to, can you see that? A lot of substitution, oh, they are very nice. I wouldn't be this nice if I were IB. Anyway, it doesn't mean I'm nice, okay? I'm not just nice on paper. Alright, so from u is equal to this, we start by saying du is equal to, du dx is equal to 3x squared, right? Which means that dx, is it okay to write dx is equal to du over 3x squared? Okay? So, the entire question has been transformed into something like this. The original question, integral x squared exponential x cubed plus 1 dx is now integral x squared exponential u. Yes? Now du now becomes du over 3x squared. So the idea is that the second part is gone. If your substitution does not lead to the cancellation of the other one, then you have not used the right function as u. That's one thing I want you to learn from question 1. Okay? So, with this now, what do we have? Together.
1 over 3.
1 over 3 Integral exponential u du. And of course, exponential function is the guy that doesn't run away in that function village story, right? I'll differentiate you, it doesn't move. I'll integrate you, it doesn't move. Who are you? I'm exponential x. It doesn't want to go because it can never change. So you can scare everybody to all he cares. It's not moving because you can't scare me. Okay? So this is going to be 1 over 3 exponential u plus c. Can we substitute back? And that's 1 over 3 exponential x cubed plus 1 plus c. If we try to differentiate this function, let's try. 1 over 3 will stay away. Remember, exponential derivative is copy and paste and differentiate the power. If you copy and paste and differentiate the power, you get 3x squared. That 3 will cancel this, x squared will stay. And of course, the derivative of this constant is 0, so it vanishes. Okay? So let's try number 5. No, 1e. 1e is also exponential function. Oh no. Let's change that. Give me one. Or do you prefer we do 1e?
How about we do D?
C or D? Choose one. D. Okay. D. So 1D. 1D says integrate 2x cos x squared minus 3 dx using u equals x squared minus 3. Okay? So from there, the u, the x is what? 2x. And that implies that your dx is equal to
U over 2.
du over 2x. Okay? So if you substitute, the original function now is what? Integral. So I always like to write the function first, the original problem. It's now becoming integral of 2x cos u du over 2x. So even the 2 is gone. So we are left with the integral of cos u du. You cannot integrate cos u with respect to x. That's the whole point of this transformation. And you remember, derivative of sine is cos. So integral of cos must be plus sine, not minus. Okay? So that will be sine u plus c. And that is just sine of x squared minus 3 plus c. And that's all. Okay? I'll take one in number 2. And what's that sound? Oh, okay. I thought I had a sound from the camera. I'm like, wait, I charged it fully. What's going on? So let's take one from number 2. The first class of tomorrow will be practice. It might be a short test, it might be self-practice. I don't know yet. Depends on how I sleep and wake up. Anyways, so what will be the first part? Which one will you prefer that we do together? In number 2. You have about 7 questions there. Let's pick one.
Let's do 4. Wait, no, 6. 6.
For 6. It loves even number. Anyone want to support his motion?
Did you swap the Roman numerals for 4 and 6?
Yeah.
Say that again?
Did you swap the Roman numerals for 4 and 6?
Yeah.
4 and 6?
Yes.
Six
I think that's why I was confused.
Yeah,
Wait. What's wrong with 4 and 6?
because it's VIIB.
Yeah.
Mr. Daniel, also
Okay.
because now the question 9, like those 3, they appeared on 8 as well.
They appear on 8?
Yeah.
Okay. Just don't kill me today. I think I copied that and I was supposed to edit that. So question 9 does not exist basically. Because it's on question 8. Just renumber it. Sorry. Anyway, let's quickly take one question more. Quickly.
Can we do 6?
Which of the... Okay. The original 6 or the intended 6?
The intended 6.
The intended 6. Does everybody agree with that?
Yeah.
So the intended 6. Oh no. What is wrong with me? Maybe I was eating food while I was typing this.
Maybe.
You know, the brain doesn't function simultaneously sometimes. It focuses on food. It's like someone giving you gossip. You can't concentrate with your mouth on work when you are listening to gossip. Okay.
Sure.
So the integral of the square root of x cubed plus x. Then you have 3x squared plus 1 dx. Which one do you think would be the u, Nakita? And why? Which of this? It has to be either this or this, right? Which one would be the u? Say that again? X cubed plus x. Do you agree with her?
Yes.
Because when you differentiate it, the derivative is waiting for you. You're right. Don't doubt yourself. Okay? When you differentiate that, the derivative is waiting for you. So don't say the u is everything, including square root. No. U is what you have under the square root. Because it's easy for you to integrate u raised to power half. Understand? So she's right. Let u be x cubed plus x. If you are dealing with an algebraic function, the higher degree will definitely be your u, such that when you differentiate, the lower degree should be the other partner that will be eliminated after you simplify, of course. Because sometimes this could be something that you need to factorize to get this. You have to do that. You see that when you practice more problems. Anyways, so if that is the case, then the u dx is going to be 3x squared plus 1. So they can swap position, which implies that the x is equal to the u all over 3x squared plus 1. Am I making sense?
Yes.
As a result of this, the original problem is transformed into what? Integral, yes? Square root of u, huh? This is still 3x squared plus 1. And now this is the u over
3x squared plus 1.
And when that is gone, the problem is now transformed into u to power half du. Yes? So what I'm trying to say is that this could have been something like 6x squared plus 2. So when you get here, you won't see that cancellation easily. Then you have to factorize 2 out of here. You do your cancellation, 2 escapes, and you continue. Okay? So this will be u raised to power, remember half plus 1, divided by half plus 1. You don't have to write plus 1, you can write the 3 over 2 directly. So u to power 3 over 2, divided by 3 over 2 plus c. When you have fraction over fraction, the denominator comes back up. So that is 2u raised to power 3 over 2, everything over 3 plus c. So let's substitute back. The reason I didn't substitute immediately is I'll be writing too many things while I'm trying to simplify. So that's lazy me. Okay? I might be a rainbow ship today, but I'm still lazy. Okay? So 2, yes, x cubed plus x, everything raised to power 3 over 2. Don't waste your time writing square root raised to power 3. That's the story for, you don't waste your time on that. Then plus c. Any question? So this is the first class of our substitution. Even though we still have a few minutes, I think we should use that to take a class picture with Mr. Brandy. Welcome back, Mr. Brandy. You missed my graduation photo, so this is like a remix.